So I want it to switch on. It will be in the on state. Yes. And you can communicate. Please switch off. The data is not getting communicated. The constraint nodes can be classified as the devices that are very constrained in resources, may communicate infrequently to transmit a few bytes of data, and may have limited security and management capabilities. So these data needs to have an IP adaptation model, as nodes communicate through gateways and proxies. The second type is a device with enough power and capabilities to implement stripped down IP stack or non-IP stack. In this case, we may implement either an optimized IP stack and directly communicate with the application layer servers, or go for the IP or non-IP stack and communicate through gateways and proxies. There are two ways. Directly also you can communicate, through the gateways also you can communicate. The third point is devices that are similar to generic PCs in terms of computing and power resources, but they have constrained networking capabilities such as bandwidth, as I already discussed about this. So these nodes usually implement a full stack, that is adaptation model, but network design and application behavior must cope with the bandwidth constraints. Very, very important thing. Finally, we can say that in constrained nodes, the cost of computing power, memory, storage resources, and power consumptions are generally decreasing. At the same time, networking technologies continues to improve and offer more bandwidth and reliability. That is all about constrained nodes. Let us consider the constrained networks. Here, low speed connections, that is modems, demonstrated that IP could run over low bandwidth networks. So high speed communications are not usable by some of the IoT devices in the last point. The reasons for that is, which includes the implementation of technologies with low bandwidth, limited distance and bandwidth due to regardless of transmit power and lack of limited network services. When we say that a constrained network can have high latency and high potential for packet loss. If speed is increased, there is a possibility of packet loss. Constrained networks are often referred to as low power and lossy networks. Here, communication is going to be a little bit difficult. Constrained networks operate between the few kilobytes to few hundred kilobytes and may utilize a star, mesh, or combined network topologies for ensuring the operations. Next comes to the IP versions. As you are all knowing about this, already studied the versions of IPv, Internet Protocol versions 4 and 6. So IETF has been working with the transforming between IPv4 to IPv6. The main driving force has been the lack of address space in IPv4 as the internet has grown. IPv6 has much larger range of addresses that should not be exhausted for the foreseeable futures. Today, both versions of IP run over the internet, but most traffic is still in IPv4. Internet of Things has the internet itself and both IPv4 and IPv6 versions concurrently. You can go for either IPv4 or IPv6. Both will going to support the Internet of Things. The following are the same of the main factors applicable to IPv4 and IPv6. Support in an IoT solutions. First point, this is application protocol, cellular providers and technologies, serial communications, IPv6 application layer. As you see that IP, that is application protocol, where the IoT devices implementing Ethernet or Wi-Fi interfaces can communicate over both IPv4 and IPv6, but the application protocol may decide the choice of IP versions. There are two things in this. For example, the SCADA protocols such as DNP3 over IP, then Modbus TCP, or the IEC 60870 5104 standards are specified only in IPv4. There are no known protocol or known production implementation by vendors of these protocols over the IPv6 today. For IoT devices with applications protocols defined by IETF such as HTTP, HTTPS, COAP, MQTT and XMPP, both IP versions are supported. The selection of IP versions is only dependent on the implementation, which application that you are going to use. Based on that, the protocols you can use. Cellular providers and technologies. As we are all knowing that there are 2G, 3G, 4G, 5G cellular networks are going to exist. But IoT devices with cellular modems are dependent on the generation of the cellular technology. They provide is the first three generations of data services: GPRS, H and 3G, that is IPv4 network based on the protocol versions. Consequently, if IPv6, if you are going to use it, these generations, it must be tunneled over IPv4. Directly you cannot able to use it. So it should be tunneled through the IPv4.